continuing with part 2 of our factoring. Number 47 on page 71 is still a difference of squares. So you can see that the first term is a perfect square because 4x squared times 4x squared is equal to 16x to the 4th. So basically what I'm trying to get at here is anytime your exponent is even, it can be a perfect square. So look more closely at those if the exponent is even. So if it's set to the 10th power, it would be 4x to the 5th times 4x to the 5th. And if it's set to the 100th power, it would be 4x to the 50th times 4x to the 50th. But if it's set to the 25th, that wouldn't work because 25 doesn't cut in half. Because remember, with our exponent rules, you add the exponents when you multiply. So just be careful with that. They're not always going to say squared. Sometimes that exponent just might be even. But basically what I'm getting at is this one factors into 4x squared minus 9 and 4x squared plus 9. And again, the middle terms are going to cancel out just like those conjugates that we had. Okay, now we're going to come to the cubes. And there is a pattern for the cubes, and some people have a hard time with it. So again, some people remember the acronym SOAP. And SOAP stands for same, opposite, always positive. And that's talking about the sign. Okay? So if you have taken a look at your pattern, notice that this is a binomial, and this is a binomial, and here's a trinomial and a trinomial. If you look more closely at that, you're going to see that this is A and B, and this is A and B, and that this is A squared times AB plus B squared. So if you know one, you pretty much know both of them. Well, that's where this comes in handy because that helps you remember the signs. The sign is the same as the one that you're factoring. If this is a sum or difference of cubes, this is the opposite of the one that you're factoring, and the last one is always positive. So now all you have to remember is that this is squared and this is squared. So again, on the difference one, the sign is the same, the opposite, and always positive. So SOAP sometimes helps you remember the pattern. Okay, so let's take a look at this example and see if we can use our pattern to factor that. This is what we call a sum of cubes because this is a perfect cube and 27 is a perfect cube. Do you all know where the cube root button is on your calculator? Make sure you know how to use that. It's under math number 4, isn't it? Okay. So the cube root of 27 is 3. So this is x to the 3rd plus 3 to the 3rd. Now the reason I write it like that, did you find it? Is it 3? So 3 to the 3rd power is 27. So now I know that A is x and B is 3, so I can use my SOAP's pattern as long as I have recognized this as a sum of cubes as x plus 3, because it's the same, times x squared minus 3 times x, and plus, because that one's always positive, and 3 squared is 9. So you can multiply this back out, and you should have your middle terms to cancel out. So since we just finished that, let's practice that. Just to double check ourselves, isn't this times this equal to x cubed plus 27? So x times x squared minus 3x plus 9 plus 3 times x squared minus 3x plus 9. And I want to check to see if those middle terms cancel out. So this is x to the 3rd minus 3x squared plus 9x plus 3x squared minus 9x plus 27. So you can see what happens is that the negative 3x squared and the positive 3x squared cancel out, and the 9x and the negative 9x cancel out. So this does check, because when we multiply these back together, don't we get what we started with? So factoring is the undoing of multiplying. So I wanted just to prove to you that SOAP does work. Okay? I'm going to pause here for a moment with our... All right, I wanted to do one more example. This is almost 63. And I say almost because if you're looking at the book, 63 is plus. But I wanted to make sure and do a difference, so I changed the problem slightly. So, again, pick up that calculator. Is 64 a perfect cube? Is something times something times something 64? So, isn't it 4? So this is really 4x cubed. And notice that I'm raising 4 to the third power as well. Isn't 4x times 4x times 4x equal to 64 cubed? So what I'm getting at is that A is going to be 4x, and B, just like it was in the last problem, is 27. 27 is one of those cubes you're going to see all the time. So if we're using SOAP, we're going to factor this as 4x minus 3, because it's the same. And then it's going to be a squared. And here's where people make a mistake. A squared is not 4x squared. It is 16x squared, because you have to square the 4 as well. That's why I put that in the parentheses. And it's going to be the opposite of 4x times 3. So that's 12x. Remember, this is 4x times 3. This is A times B. And then it's going to be always positive. And 3 squared is 9. Okay? So that's how we factor that one. All right, so we've got some practice problems.